We start this new unit on polynomial functions with an introduction to the standard format of a polynomial function. So we need to understand what the standard form is and all of the different parts that go with the standard form. Now, at this point in the year, through Algebra 2 and Algebra 1, you should have worked with at least 2 or 3 polynomial functions at this point and should be kind of familiar with the format. But let's just talk about a few of the pieces that goes along with the polynomial function. So you can see here this generic form. We have lots of variables going on here: a to the n, x to the n, plus a n minus 1, x n minus 1, and down all the way a to the 0. And so that can be a little bit confusing unless we, say, put some numbers in it. So what I'd like to do is just kind of give you a few examples of what we're talking about here. So if you look down here at the common types of polynomials, you can see we're going to have a constant, a linear, quadratic, a cubic, a quartic. And so we have the standard form written with all the a's and the b's and the x's and the zeros and all of that stuff. I'm going to go ahead and give you an example of each, just simply with numbers and how you would normally see it in a problem. So the first one is a constant function. A lot of times people don't think about the constant function being a polynomial function, but it actually is. And what defines the polynomial function is the fact that we have a variable that is written to an exponent that is a whole number. Sometimes you'll see in textbooks say that it is a positive integer, which is basically a whole number. Well, the variable that has a whole number integer in this case is an understood x to the 0 power. And if you recall, x to the 0 power is equal to 1. And so since x to the 0 is equal to 1, we tend not to write it. So f of x equals 4, f of x equals 2, f of x equals negative 3. These are all constant functions. Now, hopefully you remember that a constant function gives you what we would call a horizontal line. And so anytime you see f of x equals to just some singular number without the variable there, we're looking at a horizontal line. Then we moved into linear. And linear was something of this nature. Say f of x equals 2x plus 1. And so again, the constant value would have an x to the 0 power that's understood. Now, a lot of y'all learned this as y equals mx plus b, or the slope-intercept form. And this is just a standard form of a linear polynomial. So the reason it's linear is because its degree is at 1. And so you can see here the highest exponent value for the variable is what we would call the degree. And that degree is going to tell us a number of things. It's going to tell us how many solutions the polynomial has, which is also going to tell us how many zeros or how many roots we're dealing with. And so you learned how to graph linear functions. And then as you moved further into algebra, you got to quadratics. And we just finished our quadratic unit, and say its standard form would be x squared plus 2x plus 3. And we can see that this has a degree of 2 because the highest exponent value is 2. And we could continue to just build these. So x to the third, x squared, x, and we could write it like that, and that would be a cubic. And of course you can see that our highest exponent, or our degree, is just building up higher and higher and higher. And so we tend to call lower level polynomials various names. As we get higher into the degree, we tend to just call them by their degree. And so we might call a quartic a 4th degree polynomial. Also, do not be confused with monomials, binomials, and trinomials. The amount of terms in them just doesn't define what type they are. It just tells you how many terms they are. Monomials and binomials and trinomials are all forms of polynomials as well. So we have a number of things going on here. When we write the polynomial function in standard form with the degree value, or the highest exponent value, written at the beginning, we have a coefficient that is attached to that variable. We call that coefficient the leading coefficient. And so you need to be familiar with the leading coefficient. You also need to be familiar with the constant values. If we have a leading coefficient that's not there, it's an understood 1 if that x does not show it. So these are just some of the basic terms and the way to write polynomial functions in standard form that you need to be familiar with. So also understand that the degree indicates the number of solutions or the root, and solutions, roots, and zeros are basically interchangeable. Alright, so that's a good start and introduction to polynomial functions. So we'll start this video taking a look at an example of polynomial functions. And so in these problems, we're going to be basically asking you to identify whether you're dealing with a polynomial function, put it in standard form, and then identify a number of the parts. And so you can look at example number 1 and you can see that we have a series of exponents. They all seem to be whole numbers, and if you remember, 7 is a constant value, so that's understood to be x to the 0. So that tells us that we are dealing with a polynomial function. However, to write it in standard form, it must go from the highest degree value or highest exponent value down to the lowest exponent value. So we need to rearrange these. Now keep in mind that the coefficient and of course the sign with the coefficient kind of all go together. So we can see that is one term, this is another term, and of course this is another term. And so when we move these around, we need to make sure that the signs and the coefficient values move with it. And so you can see here in the solution, f of x equals -3 x to the 4th plus 1/2 x squared minus 7. And so we have a degree of 4. Now notice that we technically have a value missing here. We have a 0 x to the 3rd, if you will, plus 1/2 x squared minus 7. And so you can see here that the x to the 3rd term is missing. It's understood to have a 0 coefficient. However, in this particular case, to write it in standard form, it's not necessary to write the x to the 3rd term if it's being represented with a 0. So it will be left as a blank exponent there. So the degree is still 4, even though you don't see 4 exponents, but the highest exponent value is a 4. And so since it's a 4th degree polynomial, that function type is called a quartic, and then the coefficient that is going with the degree variable is -3, so that is the leading coefficient. So before you can identify any of these parts right here, you must put it in standard form. So let's take a look at some examples. If you haven't had a chance to work sample problem 1 yet, parts A, B, and C, go ahead and take a second to do that and then come back and see the solutions. Okay, so let's take a look at this first one. It says decide whether it's a polynomial function. So in order for us to make this determination, the first thing we need to do is determine if the exponents are whole numbers. And so if we look at this, we can see we have x to the 3rd and then we have 3 to the x power. That variable right there in the exponent is not a whole number, so this is not a polynomial function. So we can just go ahead and stop at that point. There's no need trying to rewrite anything. As well with part B, we have an exponent that is a negative. Now the negative is an integer, but it is not a whole number. And so again, that is not a polynomial function. Lastly, we have C, and this is one that usually tricks people up because they see the pi and they see the radical and they see the various strange symbols and they think to themselves that it wouldn't be a polynomial function. But if you really look at this, everything has exponent that is a whole number. So we have x to the 1st, x to the 2nd, and x to the 0. Now of course x to the 1st and x to the 0 aren't necessarily written like that, but they're understood to be there. So that makes this a polynomial function that we need to write in standard form. So now I need to rearrange this with the highest exponent first. Now keep in mind the coefficient, whether it's a symbol like pi or a radical value, has to go with that. So we're going to say pi x squared minus 0.5x minus the square root of 2. We can see that our degree is 2. Our leading coefficient is pi. And if our degree is 2, then we are dealing with a quadratic equation. It's not a quadratic equation that you're probably accustomed to seeing, but nonetheless it is still representing a quadratic. Alright, well that's some good examples on identifying polynomials.